Hello Math 2, this is Mrs. Bricky, and this video is for Math 2, Unit 4, Lesson 3 on angles, lines, and triangles. This lesson is just reviewing some of the items that you learned from prior classes. The first is the triangle angle sum theorem. The sum of the interior of the angles of a triangle is 180 degrees. So that means if I have a triangle, maybe this triangle ABC, if I add up angle A, angle B, and angle C, it will always equal 180 degrees for every triangle. We also wanted to review the types of triangles with you. An equilateral triangle is a triangle that has all three side lengths the same. And just as a reminder, these markings are used when lengths are equal. An isosceles triangle is a triangle in which two of the side lengths are equal, and if none of the side lengths are equal, it's called a scalene triangle. What connection is there between side lengths and angles? Well, if you know that two sides are congruent, then you know that the angles opposite them are congruent. And the reverse of that is also true. If you know two angles are congruent, then you know the sides opposite them are congruent. If the angles across from congruent sides are congruent, what size are the angles in an equilateral triangle? Well, since this side and this side and this side are all equal, we know that these three angles have to be equal. But because of the angle sum formula, we know that all of those angles have to add up to 180. So if we add these angles together, it has to equal 180 degrees. That means 3x is equal to 180 degrees, and that means each of the angles is 60 degrees. If you have a straight line, you can think of it as having 180 degree angles. And we use that most often when that angle is broken up into parts. So for example, if I know that this angle x is right next to this angle that is 55 degrees, and if this side forms a straight line, I know that those two angles have to add up to 180 degrees. So I can figure out what size the angle x is by subtracting from 180 the 55. So 180 minus 55 is equal to 125, so I know that x is 125 degrees. All right, on this first diagram, we're trying to find the measure of that angle that is marked x. So we know that the angles in a triangle have to add up to 180 degrees. So to solve for x, we just need to subtract the two angles that we know from 180. 180 minus 37 and minus 24 is 119 degrees. For this diagram, we're going to have to do it in a couple of parts. So we're looking for angle y up at the top, but we only have one other angle inside the triangle, which is 79 degrees. We do have this straight angle right here, 104 on one side. We can use the 104 to calculate this angle. So 180 minus 104 is 76. So this angle is 76 degrees. And now we can calculate y. It's 180 minus 79 minus 76, which is 25 degrees. For this diagram, we're trying to find the measure of angles 1, 2, and 3. Well, to find the measure of angle 1, we can focus on this small triangle right here. We know two of the angles in that triangle, so we can figure out the third by subtracting the two that we know from 180. So 180 minus 66 minus 84 will give us angle 1. So angle 1 is 30 degrees. I'm going to find angle 3 next. Angle 3 we can find by using this straight angle right here. We know that angle 3 and that 84-degree angle have to add up to 180. So if we do 180 minus 84, that will give us the measure of angle 3. That's 96 degrees. Finally, we're looking for the measure of angle 2. Well, to find the measure of angle 2, we can use this triangle right here. So if we do 180 minus 96 minus 43, that should give us angle 2. 41 degrees. Now, in this diagram, there's kind of a cool way to check your work. If you, let me get these out of the way. If you focus on that largest triangle, it has 3 angles as well. It has an angle of 43, an angle of 66, and then the third angle is these two added together, which is 71. If we add those 3 numbers together, we should get 180. And this is kind of a good way of checking ourselves. 66 plus 71 plus 43, and that is 180. So that means that we've probably done all of our work correctly. Okay, for the video, I'm going to go ahead and skip this. I wanted to remind you about vertical angles as well. If you have a couple of intersecting lines, that creates 2 sets of vertical angles. So those angles that are across from each other are called vertical angles, and vertical angles have the same measure. So this angle y is equal to this angle y over here. Please note that the lines have to be straight for this to be true. So, for example, angle C and angle D are not vertical because we don't have 2 straight lines. This one is not a straight line. It has a kind of a kink in it, I guess. So angle C and angle D do not have the same measure. It has to be 2 perfectly straight lines in order to create vertical angles. When we have 2 parallel lines that are crossed by or cut by a transversal, you can see that it forms many angles that are equivalent to each other. For example, we've got vertical angles here and another set of vertical angles here. But the corresponding angles are also equal. So if this one I marked in orange, it's going to be the same as this one, and it has a vertical angle as well. So we have these 4 angles that are marked in orange that are all congruent, and these 4 angles that are marked in pink are all congruent. You might remember some of the angle pair names like corresponding angles or alternate interior angles. There's a lot of great relationships among all these different angles. We also have, sorry, let me go back to that for 1 second. Whoops. We also have a lot of straight angle pairs in a diagram like this. So for example, in this part of the diagram, you can see that the pink and the orange angle form a straight angle, and that means the pink plus the orange is equal to 180. Okay, so we've got a diagram here that has a couple of parallel lines M and N, and we've got a couple of transversals, and we are going to try to find the measure of all of the angles in this diagram. So we can start by measuring or writing down our vertical angles, 46 and 46. We've got these straight lines, which allow us to calculate the other side of the vertical angles. So 180 minus 58 gives us 122. We have let's see, that other side, 180 minus 46 gives us 134. So we have another angle that is 58 degrees right here. Those are corresponding angles. You can see this one and this one are the same because they're coming from this transversal with the two parallel lines. We can use the triangle right here if we want to calculate this angle right here. So 180 minus 58 minus 46 gives us 76. And this angle right here is also a 46-degree angle. And that's because it is the corresponding angle for this one. You can see that transversal right there creates those two angles. Okay, we've got more vertical angles up at the top. If this one is 58, then the one opposite it is 58. And we've got a 46 and a 46, and we also have a 76 and another 76. All right, so we have labeled all of those angles in that diagram. Okay, parallel lines below are cut by a transversal. We're going to set up an equation to solve for x, and then we're going to determine the size of the angle marked with a question mark. So because these are corresponding angles, we know they are the same angle measure. So we're going to set up the equation 2x minus 45 is equal to x plus 35. So to solve for that equation, I'm going to subtract x. Remember, if we have a 2x and we're subtracting x, that's the same as subtracting 1x. So that leaves us with 1x. And then I'm also going to add 45. So that adds up to 35 plus 45 is 80. So that means x is equal to 80. Well, if x is equal to 80, then this angle itself is 115 degrees because 80 plus 35 is 115. That's going to allow us to calculate this guy because if we do 180 minus 115, that will give us its measure, which is 65 degrees. Okay, there's a couple of ways that you could approach this problem. You could realize that this is 120 as well. If you want, you could, that's probably a good, I'm going to do it that way. So this angle is also 120 degrees, and these two form a straight angle. That means when I add them together, they equal 180 degrees. So 11x plus 125 is equal to 180 degrees. So if I subtract 125, that's equal to 55. So I have 11x is equal to 55, which tells us that x is equal to 5. On this equation, or on this problem, it just asks us to solve for x, so we are finished. Okay, one last thing to review is the Pythagorean theorem. We have reviewed it a little bit this year. I wanted to show you these examples that have radicals in them because sometimes that throws people off. So remember, the Pythagorean theorem tells us that if we have a right triangle, that a squared plus b squared is equal to c squared, or the leg squared plus the other leg squared is equal to the hypotenuse squared. So if we want to set up an equation here, we can do that to help us solve for x. So leg squared plus other leg squared is equal to hypotenuse squared. Now, if you have a side length like root 37, and it's very, very much a good idea to maybe put it in parentheses in case you need them. So sometimes in math you need to have a grouping symbol and sometimes you don't. And unless you are really good at determining when, it's a good idea to use one. On this second triangle, we're going to have to use grouping symbols for sure. On this one, though, they aren't necessary, but if you aren't completely sure, the safest thing is to put it in a grouping symbol. So if we square 37's square root, that is 37, and then 9 squared is 81. So that gives us x squared is equal to, let's see, 81 minus 37 gives us 44. And if we take the square root of both sides, that gives us 2 root 11. We solved equations using square roots earlier this year. Usually when we are doing that, we have two answers and we use the plus or minus symbol. But in this case, because we were talking about the side length of a triangle, we know that we want to select the positive answer. All right, let's do one more. This is our last problem. So leg squared plus other leg squared equals hypotenuse squared. So 16 squared plus the other leg is 5 root 2. Because that number has like a coefficient, it's really important that we put it in parentheses. 16 squared plus 5 root squared is equal to x squared. Well, 16 squared is 256. And 5 root 2 squared is 50. Let me make sure. Yep. So 256 plus 50, we can combine those to get 306. And then to get our final answer, we would use a square root. It's possible that square root simplifies. I don't have the right calculator to, I don't know that one off the top of my head. Let's see. 3 root 34. So that's the hypotenuse of that triangle. Sometimes, especially if it's numbers like radicals that you aren't as familiar with, it can be a good idea to look at the decimals of the side lengths and see if they are logical. This one is about 7.07, and 3 root 34 is roughly 17.5. So, you should have a hypotenuse length that is the longest, and those numbers look very reasonable for this triangle. So that's kind of a good way to sort of confirm that you have been doing the problem correctly. All right, that's it for this lesson. Thanks so much. Make sure you get your assignments done.